Let us see some multiple choice questions on Fourier transforms. Let's start with the first question. The first question is as follows. The time domain representation of a signal is called A. Spectrum, B. Waveform, C. Time, D. Frequency. Okay. So, we have seen earlier in so many sessions that a signal when is represented in the form of a time domain is called as a waveform, is it not? So, the answer is waveform. So, if I take a time domain representation of a signal and it is called as a waveform. Second question is as follows. The frequency domain representation of a signal is called. Okay, the choices are A. Spectrum, B. Waveform, C. Time, and D. Frequency. So, we have seen earlier, or we also are aware of the fact that a signal in frequency domain representation is represented by the name spectrum. So, we always call it the spectrum of the signal. So, the answer is A. Okay, let us see this here. Let us see this. This is a time domain representation of a signal. Okay. So, this is the time domain representation. What we call this? We call this as a waveform. Okay. Now, the same signal if I represent it in the frequency domain, that is, let us say I have something like this. Okay. Then this is in the terms of frequency. So, let us say this is certain frequency and this is certain frequency and this is x of f. So, it is a frequency domain. This is called as a spectrum. Okay. So, if you see this, the waveform is continuous whereas the spectrum is discrete. So, this is called as a spectrum, this is called as a waveform. Now, let us look at the third question. The third question is as follows. The amplitudes of the components in the frequency spectrum of the signal are peak values, RMS amplitudes, their average values, or D, none of the above. It means we are showing you the peaks, isn't it? We have, when we draw a frequency spectrum, we are drawing it with a certain amplitude. What does that amplitude represent? Does it represent the peak value? Does it represent the average value? Does it represent the RMS value, or is something which is different from all this? So, let us see the answer. The answer is it is a peak amplitude. So, whenever I draw the amplitude of a frequency spectrum of a certain signal which is a continuous in time domain, then I will get a spectrum whose amplitudes are the peak values of the signal. They are not average, they are not RMS, so they are all peak values. The question is as follows. Once a waveform is established, it can be described in time domain A, then it can be described in frequency domain, or it can be described in both A and B, and it cannot be described. That is the last question. So, when a waveform is established, that means when you have a waveform that is generated, I can represent the waveform in the time domain, or I can represent the waveform in frequency domain, or I can have a both time and frequency domain representation, or a signal which is established cannot be represented. These are the choices given to you. So, what is the answer? When a signal is generated or established, we can either represent it in terms of time or frequency. Both are possible. So, the answer is C. Okay. So, we have seen that 100 reference is a simple question that is being asked. Let us see the fifth question. If the frequency spectrum of a signal is defined, its time domain function is A. Simultaneously determined, B. Uniquely determined, C. Both A and B, and D. None. So, what is the answer? So, the question again I will read. If the frequency spectrum of a signal is defined, its time domain function is simultaneously defined, or it is uniquely defined, or it can be simultaneously and uniquely defined, and it cannot be defined at all. The answer is it can be simultaneously defined and also it can be uniquely defined.